All right, I thought I'd go ahead and start this video by going through some examples of sentences that you just might see whenever reading and how you would then point out where the logical symbols, the connections, the implications, the connectives, whatever the operators are, how do you find those in a sentence? So I'm going to start down here at the bottom. So this one says, there are other instances in mathematics where the mathematicians whose names are attached to a result did not, so there's a negation, did not even know of the result in question. Okay? So this is pointing out that that exists. So that's like saying there are instances. So those things happen. That's like saying this A is B. And it's not necessarily saying something such as, it would not be saying A if A then B. It would literally just be saying proposition A. So these are sentences that tell you something, and that's it. It's just subject and a verb. It's not multiple sentences combined together. So in propositional logic, again, a letter or a symbol represents one individual proposition, one sentence. So looking at this next one, it says, at least in this case, Poincaré did rediscover the conformal representation. And that's it. So the only thing the sentence is saying is he did rediscover. So that's, again, just a sentence. Sentence A. In this sentence, it says, it is not uncommon in mathematics that the name normally attached to a mathematical concept is not that of the, okay, so you have not uncommon, not that of the original discoverer. So you could do your part in splitting this into multiple sentences and connecting them. But still, in this particular sentence, it's still just saying it is not uncommon. So there is this one sentence. So again, this is just like one proposition. So that you can see that in these particular more complicated sentences, a lot of times it's just making a statement. It's just giving you some proposition. Here, Beltrami's projective representation is sometimes called the Klein representation. So again, your subject, verb, predicate, right? It's just one overall sentence, A. The conformal representation is, however, commonly referred to as the Poincaré model because, so now it's giving you reasons, because his discovery of this representation is better known than the original work. So this might be something you could turn into an if-then, saying that if it's true that his rediscovery is better known, then it will commonly be referred to as the Poincaré model. So this might be a case where you could, simply because of the word because, right? That word gives you an indication that this might be one sentence and then a second sentence. So this tells you that you might have more information here that you can break apart, create separate propositions, and then possibly connect them with an if-then. All right, and then this first particular one, it's a little bit wordy, but we'll go ahead and go through it. The specific projective and, so there's an and, conformal realizations of hyperbolic geometry that I've described above were both found. Okay, so both of those things were found. So it could be a standalone sentence that maybe sentence S, specific projective, was found by Beltrami, and, okay, ampersand, conformal realizations, right? Both found. So that means this one was found, and it means this one was found. So those could be separate sentences. And then it says and published in this particular year. So this and here is actually part of what it's telling you. They were both found and published together. Okay, so it could be like this whole one long sentence here could actually be broken into two specific sentences. This one S, which refers to just the specific projective, and this one here, the conformal as well, right? Both things grouped together. So those are just some a little more complicated sentences, but that's kind of how you would see those sentences when you're just reading, when you're just going through something in general, applying the logical structure to the English words.